Welcome to a brief overview of iCompare for CATIA V5 from Tata Technologies, a CATIA integrated inspection points to digital model comparison tool. You can import from a CMM measuring machine data in various formats. Some of the notable ones here are IGES app source, Excel CSV files, Verisurf files. And you can take the input from that data file of XYZ point locations. If there are names within that file, you can actually retain the original names. And I'm going to put them into an inspection points geometrical set with the create points. Create points is going to put them in the XYZ coordinate locations as specified in that input file. I can do it from the origin that I designate if it's not the origin of the part, if there's a different origin that was used for the measurements. And the weight axes here are the geometrical set points that have been created from that data. Next, we're going to do a comparison between those points and either the entire solid, the part body, a surface extracted from that or any other element, quite frankly, from the points to whole center lines, if those are the measurements that were taken, points to curves or wireframe components, and or points from faces of the solid. In this case, I'm going to do the entire solid, so I'll just let it set for solid. I can select it in the geometry or in the specification tree. My inspection points are in this geometrical set, and I'm going to use these tolerances for comparison, and it's going to false color the points based on these colors. I can double click on any one of these values to change the value. I can use a less granular or a more granular type of tolerance checking. I can check all the points that have been created or a percentage thereof, and I'm just going to start the comparison at 100%. In order to make the comparison a little bit quicker, it's actually multi-threading with 4 different tasks that are running for the comparison purposes. And as it takes a point, it will find the nearest element of the part body in this case, or the surface if we had selected it, the wireframe if we had selected it. Take the normal from that part body surface to the point, and that is the distance that measurement will be taken, and it will then false color these points to give the indication of where they fall within the tolerance thresholds that you had set up in the main dialog. So I've got 2 in the blue area. Actually, they're 2 different. No, actually, these are the same area, blue area, and 1 in the red tolerance area. The brown plus signs that we see here scattered around are actually what we call filtered points. In this case, 0.011 is a value that I've set to say if it's beyond that, it really isn't a valid measurement point. So I'm going to put that in the filtered points set, of which in this case there are 116 out of the full set of points. 127 of them fell within the tolerance range. 2 fell on the plus side and 1 fell on the minus side, and that's the blue and the red that we see here. I want to create labels on those for documentation purposes, and the ones that I'm really interested in are the ones that are out of tolerance within those tolerance ranges, and I'm not interested in the filtered points because they were anomalous points, so I'm going to add those to the labels to be created. So in this case, he's going to create 2 for the blue and 1 for the red. The color of the label also corresponds to the false color of the point that they were created for, to give you further visual indication of the range of values that are involved. I'm going to hide the annotation plane here to make a clearer picture when I do a capture for the report. And the next thing you want to do is to actually create a report. You can create an HTML report or an Excel file based report, and you have a settings tool that allows you to set values that are going to be placed into the Excel file, allow you to change the template. I'm going to use the generic template that came with the tool for the data, the general data that's going to be placed at the top of the report. You can enter fields, data in these fields here for documentation purposes. I'm going to capture an image of the results so I can include that in my report for documentation purposes. And create the report. That I compare it that you saw flash by is a logo. You can change that to your logo in the settings files. You saw the bottom part of the captured information. This is the complete specifications of all of the results of the XYZ differentials in comparing these points to the solid. There are 3 points that just went by that are out of tolerance. And this report is in an Excel-based format. Again, you have a settings tool that allows you to determine where in this format you want it to be. You have a template as to where the data is actually annotated, so you can change either one of those to your specifications. Let me go up to the top here. So we have this generalized information about what happened in this comparison. Here's the logo that you have the ability to change. We have a false color image of the part and where the points that are out of range are and what their tolerance values are. Again, these plus signs are things that are filtered points that aren't considered to be comparison points because their distance is just too great. So it may have been an anomaly on when the measurements were taken. And then you have the Excel spreadsheet that goes down through point by point and shows you where the ones are out of tolerance and out of range. If you would like additional information, you may send an email to iCompareIt.com. So iCompareIt at TataTechnologies.com, and you can get additional information at myiCompareIt.com/CATIA. We also have an NX product, so the /CATIA will get you to the CATIA section. Thank you very much for listening.